Okay, this video is going to try to help to answer how to graph this kind of polar equation right here. Turns out that this is the graph of a general shape called a limacon. It's a soft C, really. It's not pronounced con, it's pronounced son. Okay, so first of all, here's some rules for what the equation of a limacon looks like. Okay, so a limacon has the form a plus or minus b cosine theta, or a plus or minus b sine of theta, where a is greater than 0, b is greater than 0 by convention. You could have an equation where a was negative, and you'd still get a limacon. When a is 0, you actually get a circle. But here's the conditions that tell you what kind of graph you get. Your problem, the ratio from A to B was 6 to, well, B was 6 because we had a minus sign. But if you take the absolute value, the ratio is 1. That means you have a cardioid. If the ratio of A to B is less than 1, you have a limacon with an inner loop. If it's between 1 and 2, you have a limacon with a little dimple right here. And if you have the ratio of A to B greater than or equal to 2, you have a limacon that's convex. Okay. And these are some examples of those. So on the next page, you're going to see that there's a discussion of how to graph this one. So let's take a look at what that looks like. Here's what that limacon with an inner loop looks like. How do you determine how to sketch it? Well, it can be kind of painful to go through. But the first thing you want to do is figure out the values of theta that will return you to the pole, which is this point right here, the origin. And to do that, you set r equal to 0 and solve the equation. And so it turns out these two values of theta return you to the pole. That is for theta between 0 and 2 pi inclusive. Quadrantal angles are angles along the axes. So this is a list of the quadrantal angles. So you want to make up a table if you really want to go into all this detail. For rotating this initial side from one quadrantal angle to the next, but stopping along the way for those that return you to the pole. So I have the 2 pi over 3 circled twice and the 4 pi over 3 circled twice. So from 0 to pi over 2, what happens to the cosine of theta? Well, the cosine of theta is always between -1 and 1. That kind of gives you an idea of what the possible values of r are going to be, because this factor right here, cosine of theta, can never be bigger than 1. 4 times 1 is 4. 2 plus 4 is 6. That's the biggest that r can get. So in the first quadrant, from 0 to pi over 2, cosine of theta goes from 1 to 0. 4 times that takes you from 4 to 0. And then if you add on the 2 at the start, you can see that r goes from 6 to 2. And I'm not going to go through the rest of these. You can pause the video and take a look at what happens there. But if I share my screen and go to Desmos, here is the graph of 2 plus 4 cosine of theta. The ratio is 1/2, so we do have a limacon with an inner loop. And if I click this advance button or link, it'll start rotating from 0 all the way to 2 pi and display different points. So there's when theta is 0, r is 6. And now as we advance towards pi over 2, which is right here, we should get to a value of 2. Let's see if that happens. There I am at pi over 6, pi over 4, pi over 3, and there I am at pi over 2, and the r has a value of 2. And I can continue along, clicking the advanced key so you can see how this shape traces out as theta increases from 0 to 2 pi. And there we complete one revolution around the unit circle. If I click the toggle button, by the way, we get this 2 plus 4 sine of theta. So you get the same basic shape, but it's opening up and down instead of left and right. Okay, so back to Wyzant, and let's look at your problem. 6 minus 6 cosine theta. So here, according to the definition, A equals 6, B equals 6. Or you could also say B equals negative 6. But we want to find out what values of theta make r equal to 0. That returns us to the pole. You can pause the video and look at what I did here, but it turns out that the only values of theta that make r equal to 0 are quadrantal angles. So we really only have to go from 0 to pi over 2, pi over 2 to pi, pi to 3 pi over 2. And so first, second, third, fourth quadrants, cosine of theta in the first quadrant goes from 1 to 0. You can also think of graphing the cosine function. In the first quadrant, cosine goes like that. It goes from 1 to 0. And then from pi over 2 down to pi, it drops to negative 1. And then it goes back to here and finally up to there. So that's what's happening. I'll let you fill these in. It's just 6 minus the values in this column. Okay, so if I go back to Desmos and change A to 6 and B to negative 6, there's your cardioid, but it's for sine. Toggle it to go to cosine. There's your limacon, or your cardioid. Okay, and if I click reset and then advance, there's all the possible values in increments of pi over 12, actually. Okay, and down here, there's a table that shows you those intermediate results for 0, pi over 2, it's right here, and so on. Okay, so I'll include the link to this Desmos graph as part of the solution. There you go. Hope that gave you some idea as to what's going on when you graph limacons.